Okay, so here are the four assumptions. Linearity assumption, that is y follows this model. The epsilon error terms are independent of x. The error terms follow normal distribution, and the variance of the error are all same for all values of x. So we have to now determine the residuals y minus y hat, and then we have to use the corresponding plots. The plots given here, okay, we discussed these in the previous video, and verify the validity of these assumptions. Once again, the example we are looking at is customers within 30 minutes is your X in millions and annual sales in millions. And we already have the estimated regression line right here. So if we can set up a column of y hat, and then we can go y minus y hat, and that will be your error term, and then we can plot those error terms and do the analysis for the assumptions. But instead of doing that, let's look at how to generate the residuals using data analysis. This is another way of coming up with the regression estimates, and we can use the data analysis for that. So go to data analysis, and look for regression and select that. So now we need to fill out the data ranges for the regression. So go back up. Y range is that. Okay, we're going to include labels in the first row. X. Alright, so let's check labels. Okay, constant is not 0, so we'll leave it like that. And confidence level is 95%, we'll leave it like that. And then we will use output range of that. Okay, now normally this would be okay. You can click OK and generate the regression results, but we're going to generate some plots as well. So let's generate residuals. Okay. You don't really have to have standardized residuals. Sometimes standardized residuals are useful. Standardized residual, we looked at standardization in chapter 3. That is, you take each y value minus so if you look at the value in the sample minus x minus x bar over standard deviation. So that would be the standardization. So here it will be y minus y hat divided by the standard error of y hat. Okay. That would be the standardizations, but we don't need to do that right now. Let's click residual plots also. So some of these plots will be automatically generated. You really don't need to do this because you can plot it yourself. But let's check that. Okay. So now these two plots will be generated, and we'll do the normal probability plot from StatCrunch from the website in MyStatLab. Okay. So now, so here are the output from data analysis, and you see R squared. We already computed R squared before. There are other information that's provided. We look at the other numbers a little bit later. Okay, the ANOVA table again, we'll look at it a little bit later. Okay, and here are the coefficients. So B sub 0 and B sub 1, okay, which we calculated way up here, and obviously it is the same here as well. Okay, we'll use this information in a little bit, but here is the residual output. So we have the predicted value of y, and the residuals are given here. Now if you plot the predicted y on the x-axis and the residuals on the y-axis, and you'll have a residual plot. The predicted sales is a linear function of x values. Okay, but here are the residual plots. So let's see where the residual plots are. Here you have to look for the residual plots. So here is the residual plot with x value on the x-axis and residuals on the y-axis. Okay. So that's one plot that we want to look at. Now we can look at residual in observation order. Okay, so we can look at residuals in the order in which the observations are made. Okay, you can plot this as a line plot. Okay, sometimes that would be useful. So this is residuals in observation order. This will be useful for what is called autocorrelation. We'll talk about autocorrelation a little bit later. Okay. Now we need the histogram and normal plot for the residuals, and we will use and maybe even a box plot. So what we're going to do for that is we will take the residuals and copy it into StatCrunch, and we'll generate those plots.